We're going to finish out this lecture by going through some of the ways in which the representativeness heuristic is thought to lead to systematic errors. The first example here is a case where we make an inference about a random process. We expect the outcomes of random processes to look random. So if I ask you which of the sequences of roles is more likely, you'll probably pick the first or the second one. You probably won't pick the third one, 6, 6, 6, 6, 6, 6, 6. Right? But in fact, it's more probable. Any sequence of roles is just as probable as any other sequence of roles of the same number of roles, no matter what their combination. However, this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, is smaller than this sequence, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this sequence is actually more probable than either of these sequences, simply because of the number of roles that are involved. But if they were the same length, they would still be the same likelihood. Another example of this is what's called regression towards the mean. People are just terrible at recognizing that when something deviates significantly from the standard, it will regress back towards that standard over time. And so, for instance, when the Lakers were winning NBA championships all the time, people just expected that to continue on, even though there were lots of mechanisms that were built into, for instance, the NBA draft and the fact that players age and so on, that would make that performance regress towards a more normal percentage of championships for any given team. Another way in which the representativeness heuristic can lead us to systematic error is through a failure to take base rates into account. So consider the following scenario. A gang was involved in a drive-by shooting. The city has two gangs, Greens, which comprise 85% of gang members, and Blues, who have the remaining 15%. A witness identifies the gang member as wearing blue. Court tests show the witness's reliability under similar circumstances to be 80% correct and 20% incorrect. What is the probability that the gang member was a blue, as the witness says? Well, when you ask people this, and you can stop the video and think about it for yourself, give yourself a little time to figure out what you think the answer is. In general, when you ask people, they tend to peg the likelihood of the witness report at the reliability, how many times they get it correct. So 8 out of 10 times they're correct. But what they don't take into account is the number of gang members that are green and the number of gang members that are blue. So if you've got 85 out of 100 gang members who are greens, and you get 20% of those being judged as blues, then that means that about 17 out of those 85 gang members will be misidentified as blue. So there's a very high error rate, really. When you look at the blue members, the error rate's still 20%, but now it's 20% of just 15 out of 100 gang members. And as a result, we only get 3 misidentified gang members. So there's a much higher error rate because of the differences in the base rate. And so we'll see when you calculate this using Bayes' theorem, taking that base rate into account, it turns out to be only 41% likely that the witness was correct in their identification. So sometimes the manner in which an object or event gets represented makes us insensitive to the prior probabilities involved, which is often called a failure to take base rates into account. Here's another scenario. So Bob grew up in a conservative household in Orange County, and he received his CSULB philosophy pre-law certificate as an undergraduate. He was an active undergraduate in several student organizations and student government, and expressed a strong interest in social and legal issues. After CSULB, Bob went on to get a graduate degree. His favorite news channel is Fox News. How likely is it that? Now, go and answer these questions and then stop the video and think about it for a second. So how likely is it that Bob is a Republican? How likely is it that Bob is a Republican lawyer, the double threat? And how likely is it that Bob is a lawyer, but not a Republican? And you think about that for a second, come up with their estimates. What we discover is that people will oftentimes look at the information that's provided, and they'll say that it's much more likely that Bob's a Republican lawyer than either Bob's a Republican by itself, or that Bob's a lawyer by itself. But the probability calculus tells us that a conjunction can never be any higher than the least likely conjunct. And so our estimations based on how typical Bob seems a Republican lawyer can lead us to assign probabilities to those three possibilities that violate the probability calculus. Here's another example. So you might think, well, normally I'd say that vitamin C is not very likely to prevent colds, but I just discovered that my mother and my doctor take it and they never get sick. So now what should you do? Should you leave your probability estimate alone? Should you increase your estimate, or should you decrease your estimate? Again, you can stop the video, think about it for a moment, decide what answer you give. This is probably one of the more pernicious examples of a failing of representativeness, an insensitivity to sample size. So people will often treat samples of 10, or even as 1, as though they were as representative and predictive as samples of 1,000. So we're really very strongly insensitive to sample size. And so we tend to be driven way too much by anecdotal evidence. So we're disposed to assume that whatever information we have is sufficiently representative to underwrite that inference. So in general, what we find is that people tend to underutilize facts regarding the reliability and predictive value of evidence when making inferences or acting on the basis of that inference. So for instance, positive but predictively useless information will influence wagering. People will ignore qualifying factors on evidence when the conclusion or the prediction makes sense or is consistent with that evidence. And so in the third and final lecture, we'll turn our attention to the other aspects of System 1. So we'll look at deductive reasoning in System 1, and we'll look at those context-dependent inference strategies.